Good morning, all students. In this video, we are familiar with counters. They are categorized in the two. First one is asynchronous, that is also called ripple binary counter, and second one is synchronous counter. After that, we are familiar up and down counters and what is the modulus or mod number. Let's start with basic of counters. As the name, counter is used for count something or count the number of pulses. They are divided into two categories. First one is asynchronous counter. What is the asynchronous counter? In asynchronous counter, the external clock pulse is applied to first flip-flop and the output of the first flip-flop, either Q or Q bar, is connected as the clock of the next flip-flop. Means we used a single clock which is fed to the first flip-flop, and after that the output of first flip-flop, it may be Q, that is normal output, or it may be Q bar, that is inverted output, is work as a clock for the next flip-flop. It is called asynchronous repeat counter. What is the meaning of this? Means all the flip-flop do not change state at the same time because they are not triggered at the same time or simultaneously. It is also called ripple counter. In exams, it is asked as the asynchronous counter as well as the binary ripple counter. So dear student, remember the name. It is also called ripple counter. The ripple term comes from the mode in which the clock information ripples through the counter from one flip-flop to next. Right? Next move, the important thing is the maximum clock frequency of an asynchronous counter decrease with increase the number of flip-flop because maximum clock frequency of the synchronous counter is divided by 2 की power n, whereas n is number of flip-flops or number of bits are used here. Next one, the synchronous counter. What is the meaning of synchronous counter? The main difference or definition of the synchronous counter is that the clock signal is fed all the flip-flops at the same time, okay, with the same clock pulse. The clock signal in this case is fed same time or applied to the clock inputs to all the flip-flops. In this type, all the flip-flops in the counter change state of the same time in the synchronous manner with the input clock signal. This is the main difference between the synchronous counter and the asynchronous counter. Okay, what is the benefit of this synchronous counter? In this case, propagation delay is equal to the propagation delay of one flip-flop only is respect to the total number of flip-flops used in the counter, or delay is independent of the size of the counter. Means the propagation delay is very small, so speed of the operation of the synchronous counter is very large because the propagation is delay is only respective to first flip-flop, the propagation delay of the first flip-flop, so the speed of the operation of the synchronous counter is very high. Okay, next we are going to up and down counter and the mod number or modulus. The mod number of a counter is the number of different logic states it go through before it come back to the initial state to respect the count sequence. What is the meaning of this? Mod number is the total number of states of any counter to perform it before repeating itself. That is called mod number. N bit number, if here n bit number, then to keep our n mod or status present. What is the n is the number of bit. Number of flip-flop was required is the equal to the number of bits, that is n. Divide the frequency by 2 key power n, means frequency of any flip-flop in this counter is approximately equal to f upon 2 key power n. It counts from 0 to 2 key power n minus 1. Example 4, if we have n equal to 3, that it has 2 key power 3 mode, means 8 mode or 8 states, means it counts from 0 to 7, that is 0 to 2 key power n 8 minus 1, that is 0 to 7, divided by frequency f upon 2 key power n. F upon 2 key power n means f upon 8. Okay, number of flip-flop are required. If n equal to 3, it means 3 flip-flop are required. Okay, so we can say a counter has less than 2 to the power n, so that modulus may be less than or equal to 2 to the power n or greater than or equal to 2 to the power n minus 1 plus 2 1. Okay, next one, we move to detailed study of asynchronous or binary ripple counter. As we know, binary ripple counter consists of a series connection of number of flip-flops with one clock signal is fed to first flip-flop, and then output of this flip-flop is work as clock to the next flip-flop, and the output of next is act as a clock of the next flip-flop, and so on. Okay, since flip-flops are used in the toggle mode, so we can construct counter using the flip-flop which consists the property of toggling, that is JK flip-flop. And also JK flip-flop is construct using the T flip-flop. If we tie together J or K or short, then it become the T flip-flop or D flip-flop also. Okay, it may be synchronous counter used negative as triggering as well as positive as triggered JK flip-flop. Okay, first example we can do. First one is 2-bit ripple up counter. 2-bit ripple up counter. Okay, how many bits are used in this case? 2 bits. So number of flip-flop was required, n means 2. So 2 flip-flops are designed, that is the JK flip-flop in the toggling mode, means J and K have the value of 1. So we have feed the 1, J and K also here feed 1, J or K. In this case, JK flip-flop in the toggling mode we used as a counter. Okay, we use negative as triggered flip-flop. This is a negative as clock. Okay, first clock is fed to first flip-flop, that is number is called FF0, that is flip-flop number 0, and the output of this flip-flop, that is a Q bar, is fed as a clock to the next flip-flop, that is a flip-flop number 1, and the output of the next flip-flop is there Q1. We have the output Q0 and the Q1. Okay, if we have a number of bit 2, then how many states or more? 2 key power 2 means 2 key power 2 is 4. So it is count from 0 to 3. Okay, in binary or in decimal number 0, 1, 2, 3, and then also repeat 0, 1, 2, 3, and so on. In digital or binary form, 0 because it is 2 bits, so 0 is written as 00, 1 is written in 2 bits 01, 2 10 3 11, and then repeat 00 and 01 10 11 and so on. So it is a 4 mode here, 4 states counter in 2-bit ripple up counter. Okay, what is the working of this? The counter is initially rests to sit. Okay, one thing is also here, it is a down counter or up counter. It is depend the feedback of the output to the next flip-flop. See here, Q bar is connected as a clock to the next flip-flop's input or clock, so it is called up counter. If we connect Q bar is connected as a clock of next flip-flop, that it is called down counter, or it count from down sequence, and it is count in the increasing or up counting, means 0 1 2 3, it is up counting. Okay, so initially we take all the flip-flops are reset, that is a 0 0, and now it count 1 2 3 and then repeat 0 1 2 3 and repeat 0 1 2 3. Okay, we draw the clock. It is the negative edge triggering. What is the negative edge triggering? In previous video I have explained what is the negative edge triggering and the positive edge triggering. In negative edge triggering, the clock is goes to from high to low, that is 1 to 0. Okay, 1 to 0, that is a negative edge triggering. In this case, because it is up counter, so all the flip-flops, that is a 2 flip-flop are used in this case because it is 2-bit up counter or asynchronous counter. Q0 or Q1 initially state are reset, that is 0 and 0. When we receive the clock pulse here, the first flip-flop is always goes to toggling mode. Okay, 0 it is goes to 1, it is goes to 1 up to first clock, that is the first negative edge triggering pulse. Okay, next the output of Q1, because now Q0 output as work as the clock of the next flip-flop, means it is the now clock for this flip-flop or this output, so we use this output as a clock for this. So this is the 0 to 1, it is goes to 0 to 1. Okay, here the change 0 to 1, or it is called positive edge triggering, not negative edge triggering. So when positive edge triggering, the flip-flop are disabled, means no change. So 0 here and also is 0 here. In this condition we have no change. Okay, next clock pulse, the flip-flop of Q0, the first flip-flop is always go toggle. Okay, 1 is goes to 0. Okay, next this clock, this output is become the clock for the next flip-flop, so it is going to 1 to 0, means negative edge triggering. So next flip-flop is enable, okay, or active. So 1 to 0, then this flip-flop, the next flip-flop is also toggle, so means 0 to 1, this is through 0 to 1. Okay, next one, this flip-flop is always toggle for the every clock pulse. So next clock pulse is coming and thus output of Q0 is 0 to 1. Okay, 0 to 1. Now this for the next flip-flop is also enable or disable due to this signal, because it is become as clock for the this flip-flop. So this is the positive edge triggering, so the output is no change, जैसा पहले था वैसे ही होगा. ठीक है, तो 0 to 1 यहाँ पे 1 था, so the output is remaining as Q and that is no change. 1 है तो 1 ही रहेगा. Next 1 to 0, because it is toggle for every clock pulse. Okay, that is the 1 to 0 is a negative edge triggering, so here also change, that is an 1 to 0. Okay, what is the output, or we can write the output, that is this is Q0 and Q1. So we write first Q0 and Q1, this is the LSB and this is the MSB. 2 0 0, then 1 0, then 0 1, 1 1 and again 0 0. See students, this is the sequence 0 0 0 1 1 0 1 1 and 0 0. This is 0 1 2 3 and repeat itself after the fourth clock pulse. So 0 1 2 3, it is a 4 state or mode 4 counter, and also repeat here again after this state. Okay, for the written work, when first clock pulse applied, flip-flop number 0 toggle at the negative edge triggering pulse, therefore Q0 goes from 0 to 1, this became a positive, so flip-flop 1 is not attend and Q1 is 0, hence the state of the counter with one clock pulse is, what is this, Q0 is 1 and Q1 is 0, so we write here Q0 Q1, that is LSB MSB, we write to 1 and 0, so on for the all the states. Okay, this is the written part for the flip-flop, and next one is the stable for the 2-bit asynchronous up counter. Here's the number of clock pulse that is counted by this counter. It is count 4 pulse, 0 1 2 3, and after after that it is repeat itself in the fifth clock pulse, that is the Q0, QM, LSB and MSB. Okay, the 0 0 0 1 1 0 and 1 1, and again it is repeat. So